right, let's do some more calculus. Woo woo! Let's do this thing. Okay, we're on daily lessons 114, and we're going to circle back to something that we've already done before. So this is pretty nice. You should have an idea going into today about this whole lesson, which is really nice. So we're going to make connections between f and f prime. That's what we've done. And then we're going to add in f double prime, which you already have a little bit of an idea about, or should, because we've talked about it a little tiny bit. So I'm actually going to start with just f prime. So something that we've done before. So remember, f prime is the slope of the tangent of f of x. So we're talking about the slope of f of x, and then this is f of x over here. So I want to know, I'm going to actually do this one first. If f prime of x is greater than 0, or I can say positive, if f prime of x is positive, think about it, the slope is positive. What is happening to f of x? Yeah, f of x is increasing. What about negative? F prime of x, the slope of the tangent is negative or less than 0. Decreasing. Because increasing again looks like this. This would be where the slope is positive. Decreasing looks like this. Positive to negative. So I'm going from positive to negative, or greater than 0 to less than 0. So if I'm talking about the slope changing from positive to negative, that would mean f of x, positive to negative. Hey, and we've talked about this before, but we're going to do it again. You'd have a relative max. Negative to positive, relative min. And I'm hoping all of this is old news for you, but if you're just learning it now, that's okay too. At least you're learning it. Woo! 0 under undefined. So if f prime of x is 0 or undefined, that means the slope is 0 or does not exist. I'm going to say that this is a potential or a possible relative min or max. Because if there's a nice smooth curve like this one, that would be where the derivative is 0. So I'm changing from negative to positive on the derivative, or decreasing to increasing on f of x. And there's going to be a point right here where the slope is 0. So the slope of f of x is 0. So that's where f prime would be equal to 0. Same thing on here, positive to negative. There's some place where the slope is 0. But you can see these are nice smooth curves. So there's things like that where it would have 0. But you could also have something like this. And remember, the derivative cannot exist at a sharp turn. This would be one of those places. This is still a relative min. This is still a relative max. But the derivative changes abruptly. The limit from the left doesn't equal the limit from the right, which is part of the two things that you need in order for a function to be differentiable. What's the first? The function has to be continuous, and the second is the limit from the left has to equal the limit from the right of the derivative. Okay, so we remember all those things, kind of jogging your memory here a little bit. Analytically find all intervals, where f of x, so I've got this function, is increasing or decreasing, or has a relative max or min. So this is kind of what we did before, where we said, well, what I do is I take the derivative and then I make a chart. So f prime of x, I'm going to say 2/3, leave the inside alone. And if you want to shut off the video right here and see if you can do the rest on your own, feel free, because this is all something you've done before. I'll stop you at the next place so you can check your work. 2/3, x plus 2 is the negative 1/3, because 2/3 minus 3/3 would be 1/3, negative 1/3, times the derivative of the inside, which is just 1, plus 0. I'm going to rewrite this, 2/3 x plus 2 to the 1/3. And so if I'm trying to figure out, before what we did was we set the derivative equal to 0 and then made a chart. Here I'm going to extend that a little bit, and don't just set the derivative equal to 0, but I want to see where is it 0 or does not exist. These are going to be critical values for f prime. So I'm going to say, well, there's no place where this derivative is 0, because there's never a place where the numerator is 0. But the denominator is equal to 0. Divide by 3 on both sides. So we get 0. Take both sides to the 3rd power. Get 0. X is equal to negative 2. So when I'm making my chart, my critical value is negative 2. So I'm going to say negative infinity to negative 2. At negative 2, f prime does not exist. And then I'm going to say -2 to infinity. And then remember, I feel like I'm going way back. You choose your favorite number between negative infinity and -2, and then substitute that back into the derivative. So let's say my favorite is -512. -512 plus 2 is still going to be negative. Raised to the 1/3 power, it's the cubed root. This would still be negative times 3. And I would get, hold on, did I miss something here? Just making sure I didn't. Cubed root, we're good. So this is still going to be negative. If I have positive infinity, or -2 to positive infinity, my favorite number in there is 3. 3 plus 2 is 5 to the 1/3 power is still going to be positive, times 3 is still going to be positive. The numerator in all this is positive, so positive divided by positive is positive. That means with f prime of x that I know f of x is decreasing, and you can look back up here and say, well, f prime is less than 0, decreasing, and increasing. Okay, so I did all this work, and then over to the right, what you should do is get a graphing calculator. I should have got mine out before, but whatever. And then you're going to graph this. So go to y equals, oh no, do I have a graphing calculator? I do. I can feel it. It's not coming out. Hold on. Was anyone worried? I'm going to edit that part out probably, but found my calculator. Yeah. Okay. So in here, I'm going to say y equals, and then I'm going to delete everything else that's in here. And this would be x plus 2 to the 1/3 or 2/3 power, because I'm graphing the original function plus 1. I can graph it right now, or I can see that my window on here is going to be -11 to 7. So I'm just looking at what is given to me already. So I'm going to change my x-min to -11, x-max to 7, and then I'm going to do the same thing for y-min and y-max. So I've got -7 to 11 here. If I graph that, I can see what's generally happening. Oh, looks like how I draw birds. Does anybody else draw birds like that? They look like they're so far away on a piece of paper. I'm going to go to my table so I can find a point. Now that I know kind of what's going on, I can see at -2, that's where something interesting was happening. So I'm going to make sure to graph that one. -1, +2. I've got -3 is 2. Let me do one more. How about I go and I do -10 is 5. 2, 3, 4, 5. And I'll do one on the other side too. How about, 6 is 5. Let's go there. 3, 4, 5. Okay, so now I can follow my curve. Be like, hey, it was like this and like this. We did it, and I want to label it. It's f of x. Okay, so all this is not new, but it's like coming back to an old friend, so we're okay. So let's keep going. How about on the next page? Again, not new. So for each of these functions below, determine the intervals where the graph of f, where the graph of f of x in this case, or g of x in this case, is increasing, decreasing, or has a relative max or relative min. The only thing that is new from before is that you will also figure out where is the derivative equal to 0 or undefined. And before we had just done ones that were equal to 0. So go ahead and shut me off if you're like, and skip to the next part to check your answer if you're like feeling good about this. If not, follow along and I'll hopefully refresh your memory. So f prime of x, 4x to the third minus 12x squared. If I want to set this equal to 0, Here, I'm actually going to factor this out, though, just so it's a little bit easier for me. So I would have 4x squared. I can take out a factor out of both. This would be x minus 3. Remember to set each of these factors equal to 0. So you'd have 4x squared equal to 0, and you'd also have x minus 3 equal to 0. Sometimes people divide by the 4x squared, and then they forget about x being equal to 0. Divide by 4, take the square root. You're still going to get 0 over here. X is equal to 3 over here. When you make your chart, I'm going to go from negative infinity to 0, because that's the first place where f prime equals 0. Then from 0 to 3, because I know at 3, f prime is equal to 0. 3 to infinity. You pick your favorite numbers in those intervals. So negative infinity to 0, I'm picking my favorite number, and I can go to any sort of f prime. So I can go up to here or here. I think the factored form is a little bit easier to substitute into because all we're looking for is positive and negative. I'm not trying to find a real number. So negative infinity to 0, let's say negative 100. If I take negative 100 squared times 4, I'm still going to get, this would be positive times positive. Negative 100 minus 3 is going to be negative. So if I have a positive times a negative, I would get negative. From 0 to 3, I'm going to pick 1. This would be 4 times 1 squared, positive. And really anything here is going to be positive every time. So the only thing we're really looking at is this. But 1 minus 3 is negative 2. Positive times negative 2, negative. If I'm saying 3 to infinity, pick your favorite number. So I've got 3, let's say 10. This would be positive, 10 minus 3, positive. So I've got positive. So negative, negative, positive. And then it says we have to determine the intervals where the graph is increasing, decreasing, and show your analysis and justify your answer. I just showed my analysis, but I need to justify my answer and actually say what my answer is. So I'm going to say f is decreasing on the intervals negative infinity to 0 and 0 to 3. And my reasoning as f prime of x is less than 0. Or you can just say as f prime is less than 0. I'm going to say f is increasing. Remember, f is increasing where f prime is positive on the interval 3 to infinity as f prime is greater than 0. I also have to show my relative max and mins. Here's sometimes where I draw this too. Like, and you could have already put this, but f would be decreasing here, decreasing, increasing. I might draw what that looks like. Decreasing to decreasing. Right at this point, f prime of 0 will be 0, and f prime of 3 is 0. So both of these I know have horizontal tangents already because the derivative of f is equal to 0. But this one's just going decreasing, decreasing, and I can't say anything else about it. Like horizontal tangents, all I've got there. At 3, when I'm going from negative to positive, I can see I have a relative min. So I'm going to say f has a, I'm looking real quick, determine the intervals, and it doesn't say anything about the coordinates in here, so I'm okay with just putting the value of x. So I'm going to say f has a relative max, or relative min, I'm sorry, at x equals 3. And my reasoning as f prime changes from negative to positive. Because you already wrote that f is decreasing to increasing, or I'm sorry, where f is decreasing and where f is increasing, you could have used f either increasing or decreasing in your answer. But because this is what I had up here, I just kept it with f prime, changes from negative to positive. The last thing is, I would write f does not have a relative max. And my reason as f prime does not change from positive to negative. So it's saying where did these things happen, but I want to also include that in my reasoning also, just to make sure that, like, yes, whoever is reading this, if it's me, if it's an AP reader, we know for sure that you know where relative maxes and mins happen. Okay, over here, same idea. If you took the derivative of this already, or if you want to try this on your own, now would be a good time. This is to the negative first power. And I'm going to say g prime of x. I'm using the chain rule. This would be -6. Leave the inside alone. It's the negative second power times the derivative of inside, because wow, equals, this was g prime of x equals -12x over x squared plus 3 squared. And you want to figure out where this derivative is equal to 0 or does not exist. So I'm going to set the numerator equal to 0 and find out that at x equals 0, that's when g prime is equal to 0. If I set the denominator equal to 0, square root both sides, x squared plus 3 is still 0. X squared is equal to -3. There is no number that I can put in here that I square it and get a negative answer. So x squared is never equal. There's no value for x where I can get -3. So I can't do this one. So over here, I'm just going to say x is equal to 0. That's what I'm using. And I'm going to go from -infinity to 0, 0, 0 to infinity. And I know at 0, g prime is equal to 0, which means g, there's a possible relative min or max. And then remember that you substitute in a value from -infinity to 0 into the derivative. So -100, if I put that in. The denominator is always going to be positive because I have some number squared plus 3 squared again. So this will always be positive. So really I'm just looking in the numerator. Negative times -100 or any number in here would be positive. Over here, 0 to infinity, if I substitute any number into the numerator, well, again, denominator, we get positive. Into the numerator, it would be negative times a positive, which would be negative. So then you can go through and say, well, g, this where g is increasing, decreasing. At 0, increasing to decreasing would be a relative max. And because this is old stuff, well, I feel like I should do this real fast and be a good example. G has a relative max, I don't know why I'm starting with this, at x equals 0 as g prime changes from positive to negative. At x equals 0. G does not have a relative min as g prime does not change from negative to positive. Oh, I'm running out of room. I'm going to do it on the side. Okay, g, this is unorthodox, but whatever, I'm thinking and writing outside the box. G is increasing on the interval -infinity to 0 as g prime is greater than 0. G is decreasing on the interval 0 to infinity as g prime is less than 0. Okay, justified. Whew, we're 18 minutes in, and, well, a couple minutes spent finding my calculator, but we're all doing old stuff still. And now you're like, can we do new stuff? Yes. After we sum up the old stuff. Okay, the first derivative of a function identifies interval where a function is increasing, decreasing, relative max, or relative min. So you've done this before. You are a pro. If not, it's coming back to you. That's okay. In a similar fashion, the second derivative identifies where a function is concave up, concave down, or has a point of inflection. Okay, so what this is, so we're finally getting to this, concave up, concave down. So f of x, or f double prime, can tell you something about f of x. So even though the second derivative, f double prime, has the same relationship with f prime, because this one, f double prime, is the slope of f prime, it can also tell you things about concavity, the shape of the graph of f of x. So if I'm saying the second derivative, so f double prime, can tell you where a function is concave up. Concave up means like it looks like a smile. looks like this. I can be decreasing or increasing, but concave up looks like a smile. Concave down looks like a frown. Oh, so sad. Point of inflection is where it changes from one to the other. So it might be like concave up to concave down, and there's a place right here. That's a point of inflection. It also kind of looks like when those monkeys that form together in a line, the like little kid toy, whatever. But that's a point of inflection. Okay, so moving on. Now that we know those things, let's think about this. If f of x and f prime, if f double prime has the same relationship with f prime, so this one is the slope of f prime. So the things that we wrote before, ignore this middle column for right now, but if we said the things that we did before and we knew like f of x was increasing when f prime was positive, I can still do that here. So f double prime is positive, that means it's the slope of f prime. So f prime is increasing, decreasing. So this would be positive to negative, increasing to decreasing. This is a relative max, relative min. All the same relationships hold. This was a potential min or max, or a possible relative min or max. So those same relationships, because f double prime is the slope of f prime. But now we have some new relationships to also think about. If f double prime is positive, f of x is concave up. Negative, concave down. Think about it. If you're negative, you're sad. If you're positive, you're happy most of the time. Negative to positive, this is a point of inflection. And the reason why is because we would be switching from concave up to concave down. Same thing with negative to positive, point of inflection. It's the place negative to positive. It would be like right here, whereas this one would be positive to negative, be like right there. Is 0 or undefined? In this case, this is a possible point of inflection. Poi. Sounds like when people say boy, but it's like poi. Anyway, okay, on the previous page, you found that the function, we have this f of x. And so what I'm going to use is the same thing as before. So I can kind of do this because it's easy for me to look back. But what I'm going to do is the same thing that I had before. And if this is x, and I knew f prime from negative infinity to negative 2 was negative, and then at negative 2 I had does not exist. This is all okay. And then at negative 2 to infinity, oh, I'm trying to write fast and I can't write. It's positive. Okay, we knew all those things before. But now what I need to know, if f prime of x was equal to this business over here, and I'm going to rewrite it just so it's a little bit nicer to take the derivative of. So I'm writing it with a negative exponent. Can you even see that? No. What was I doing with my life, guys? That looks gross. That's negative 2 to infinity. So I rewrote this. I don't know what just happened. Something happened. Okay. So what I can do then is take the derivative, chain rule again. Did we get so lucky? Negative 1/3 times 2/3 would be negative 2/9. Leave the inside alone. My new exponent, negative 1/3 minus 3/3 would be negative 4/3. Times the derivative of the inside would just be 1. If I rewrite that, I've got negative 2 over 9 times x plus 2 to the 4/3. And I can see the place where f double prime does not exist. So again, I can't have a place where f double prime is equal to 0, although we want to be looking for that. But I can see the place again where this derivative is going to be 0 and the denominator is going to be at negative 2. Don't believe me? Try it out. Set it equal to 0, you're going to get x is equal to negative 2. Okay, so what I'm going to do then is look at f double prime and figure out, is f double prime positive or negative from negative infinity to negative 2. So again here, this is going to be something plus 2 raised to the 4/3 power. 4/3 power means you take the cubed root but you also raise it to an exponent of 4. An exponent of 4 is going to make everything positive here. The numerator is always going to be negative. So f double prime is always going to be negative, except at x equals -2, where it does not exist. Negative over here also, because try this again, but substitute any number from -2 to infinity, you're still going to get a negative answer. What this means, and we just said above, was that when f double prime is less than 0, f of x is concave down. So if this is concave down, and I said that kind of looks like a frown, or at least part of a frown. If I go back to my original function, concave down, oh look, it's kind of a frown. I can draw this over here. Look at that guy. Look, isn't he sad on this side? Isn't he sad? Look, that's my guy. Here, I'll turn him to the side. He's so sad. I'm actually not very good at frowning. I get sad sometimes, but I really actually stink at frowning. Okay, there's only one more thing that I want to do. Don't worry, I'm not doing the entire page, but I just want to show you that this is the same thing as before. So just kind of get into this one. For each of these, determine the intervals where the graph is concave up, concave down, and determine the points of inflection. This is very similar to what we did before. It's just instead of taking just the first derivative, I get to take the second derivative. Whoop whoop, more derivatives. You still get to set it equal to 0 or figure out where it doesn't exist, but there's no place where a polynomial is not going to exist. In this one, I'm still going to factor out something first, so 12x squared. I'll get 1 minus, 12x. So I get x minus 2. The places where I'm going to be looking are x equals 0 and x equals 2. When you make this time you're going to do f double prime. I'm still going to get negative infinity to 0. At 0, f double prime was 0. 0 to 2, because at 2, f double prime was 0. 2 to infinity. And just like before, what we're going to do is we're going to substitute in to f double prime, we're going to substitute into this function right here. So pick a number. Whew, I can speak. For f double prime, I'm going to pick a number from negative infinity to 0. Then I'm going to go up to f double prime, here or here, I choose the factored form, and substitute in. So if I pick, like, let's say negative 10, 12 times negative 10 is negative, negative 10 minus 2 is negative, negative times negative is positive. If I choose 1, that's in between 0 and 2, positive times a negative, negative. Pick another number. If I pick positive 100, 12 times 100, 100 minus 2, positive times positive, positive. This is the same thing like we did before, but I'm going to say f is concave up. So slightly different language on the intervals. Negative infinity to 0 and 2 to infinity as f double prime is greater than 0. F is concave down. You can see how similar this is to before. On the interval, 0 to 2 as f double prime is less than 0. And then the next one is f is, bless you, Caleb. My son just sneezed. F has a point of inflection at, and this actually says an actual point. So you need to go in, and because I can see changing from concave up to concave down right here, concave down to concave up, there's going to be a point of inflection here and here. If it asks for a point, we need to find out what f of 0 is and f of 2. And the way we do that is go up to the original function. So f of 0, x to the 4th, so 0 to the 4th minus 4 times 0 to the 3rd would be 0. F of 2, 2 to the 4th, 2 to the 4th minus 4 times 2, oh man, I hate it when I do that, 2 to the 4th minus 4 times 2 to the 3rd. I could have figured this out already in my head, but that's okay, is negative 16. So f has a point of inflection at f of 0 equals 0 and f of 2 equals negative 16. I'm just going to keep them together as, you can say as f double prime. You can do f double prime changes signs, meaning positive to negative or negative to positive, or vice versa. Okay, this is getting long. I'm going to skip out a few parts, but we're going to save this for tomorrow, just to review. Okay, thanks. Hey, by the way, I think you're amazing. I know I say this at the end of everyone, but I really am just so thankful to teach you. Thank you for working. It's not easy learning from videos, and you're doing awesome, and I couldn't be more proud. So thank you for being you. Keep it up. Please ask me if you have any questions at all. Bye.